HVAC system. HVAC system is a residential HVAC system. Is a complete home comfort system that can heat and cool your home as well as provide improved indoor air quality and humidity control. HVAC formula used to determine the required capacity of an HVAC system to remove heat. Formula simplified: Q is equals to 1.1 into CFM into delta T, where Q is equals to cooling load, BTU per hour, CFM airflow rate in cubic feet per minute, and delta T temperature difference, degree or Fahrenheit. And for metric, Q is equals to 1.2 into CFM into delta T, kg per hour. Airflow rate. To calculate the required airflow to achieve a certain thermal effect, CFM is equals to Q into 1.1 into delta T CFM. This is used when you know that desired cooling or heating capacity and the temperature difference. Sensible and latent heat. Sensible heat is responsible for a change in temperature, while latent heat involves moisture change, humidity control. Sensible heat QS is equals to 1.08 into CFM into delta T into QS, and latent heat QL is equals to 0.68 into CFM into delta W QL, where delta W is equals to change in humidity ratio. Total cooling load. Total cooling load is equals to Q total is equals to QS into plus QL. Used for air conditioning system to determine the combined load of temperature and humidity control. HVAC power consumption kilowatt used to estimate energy uses of HVAC unit is equals to P is equals to Q by COP and 3412, where P is power input in kW, Q is equals to cooling or heating load in BTU per hour, and COP is equals to coefficient of performance, and 3412 conversions factor in British thermal per BTU per hour to kilowatt, and chiller efficiency of WW by TR. The chiller efficiency is often expressed in kilowatt per ton of refrigeration tier. Kilowatt per tier is equals to total power input kilowatt by cooling capacity, where 1 ton of refrigeration kilowatt tier is equals to 12,000 BTU per hour is equals to 3.516 kilowatt. Heat transfer equation for conduction Q is equals to UA delta TQ, where Q is equals to heat transfer rate W and U overall heat transfer or coefficient of W per meter square into K. A is equals to surface area and delta T temperature difference K or degree centigrade, and commonly used to evaluate the thermal losses through the duals, walls and heat exchanges.